We use these incredibly powerful AI models every single day. But what if there's a hidden risk we're not thinking about? Today, we're going to pull back the curtain and look at how a team of researchers figured out how to literally pull secret, word-for-word information right out of an AI's memory.
So, let me ask you this. Does the AI you're using have a secret? It sounds like something out of a sci-fi movie, right? But the answer is, well, it's a lot more complicated, and frankly, a bit more concerning than you might think. What if that AI isn't just being creative? What if it's remembering and repeating things it was never, ever supposed to?
Okay, so before we dive in, let's make sure we're all on the same page. We're talking about large language models, or LLMs. These are the big, powerful AIs like GPT-2 that have been trained on just enormous amounts of text from all over the internet. Their whole job is to understand and generate language that sounds just like a human wrote it.
So let's start digging. To really get a handle on this risk, we've got to look at the difference between how we think these AIs learn and what this research shows might actually be happening inside their, digital brains.
See, the general idea has always been that these models generalize. They learn the rules, the patterns, the vibe of human language, and then they create totally new stuff. But what these researchers found is that they also memorize. And I mean perfectly recalling and spitting out text they saw during training, word for word.
And here's the crazy part. For the longest time, the experts weren't all that worried about this. The thinking was, because these models don't overfit in the traditional sense, where they do great on training data but fail on new stuff, everyone figured that significant memorization just wasn't a real problem.
But the researchers behind this paper, they had a totally different hunch. They thought, what if, even without that classic overfitting, some specific examples from the training data got so deeply burned into the model's memory that it could just repeat them on command, kind of like a digital photographic memory? So, you've got this theory, but how on earth do you prove it? Well, that brings us to the next and maybe the coolest part of the story, how they designed an attack to see if they could actually crack open the model's memory and see what was inside.
Their method was, honestly, brilliant. First, they just got the model to generate a ton of text. I mean, millions and millions of sentences. Just go. But the real magic, the secret sauce, was in step 2. They figured out this incredibly clever way to sift through that giant ocean of text to find the little nuggets of pure, memorized gold. And this is the key insight. They weren't just looking for text that sounded right. No, they were looking for text that GPT-2 found suspiciously probable compared to other simpler models. Think about it. If a sentence is really generic, like "the sky is blue," lots of models will say, yeah, that's likely. But if it's a specific secret, only the model that actually saw that secret will think it's super likely. That gap, that little bit of surprise, that was the fingerprint of a memorized secret. All right, so they ran the attack. They cracked the safe. And this is where things get really wild. What exactly did they find inside GPT-2's memory? They found a lot. I mean, a lot. Out of a relatively small batch of candidates they checked by hand, they confirmed 604 unique word-for-word sequences that were pulled directly from the training data. The safe was officially cracked wide open.
And if you want to see just how serious this is, look at this. This is one of the actual examples they pulled out. Now, we've obviously redacted it, but that's a real person's name, email, phone number, and physical address. This wasn't some random bit of text. This was sensitive, personally identifiable information, just sitting there waiting to be found.
And it went way beyond just contact info. The model had memorized a whole bunch of different stuff. We're talking news headlines, server logs, private chats from back in the day, chunks of computer code, working web addresses, and even super unique things like 128-bit UUIDs.
This right here is what the researchers called eidetic memorization, and it is mind-blowing. Think about this for a second. They pulled out this long, random-looking string of characters, a UUID, that appeared in only one single document in the entire 40-gigabyte training dataset. The model saw it once, in one place, and remembered it perfectly.
So this begs a massive question, right? Why is this even happening? If it isn't that classic overfitting problem, then what is causing these incredibly powerful models to have such a dangerously perfect memory?
So yeah, like we said, this isn't the overfitting we learned about in school. The real culprits here are a 1-2 punch. First, the absolute massive scale of these models. And second, good old data repetition. It turns out, even if some piece of info is only in one document, if it's repeated enough times within that document, it can get permanently burned into the model's memory.
And check this out. This chart just makes it so clear. When the researchers ran a specific test to extract URLs, you can see the largest version of the model, GPT-2 XL, memorized way more than its smaller siblings. The trend is totally undeniable. The bigger the model gets, the bigger its memory gets, and the bigger the privacy risk becomes.
And, you'd think something would have to be repeated hundreds of times, right? Nope. For the biggest GPT-2 model, a chunk of text only needed to show up about 33 times, and that could be within the same single document to be at a super high risk of being memorized and extractable. That's a surprisingly low bar.
Okay, so this is all pretty sobering. The obvious question is, what in the world can we do about it? So let's turn to the solutions and what this all means for the future of AI safety.
The paper lays out a few key strategies. One is a fancy technique called differential privacy, which basically adds a bit of mathematical noise during training to help protect individual data points. Another, more straightforward approach is just better data curation, like being way more aggressive about removing duplicates and filtering out sensitive stuff before you even start training. And finally, we need to be auditing these models, actively attacking them like this to find these weak spots before they're ever released.
And here's a really important takeaway. This isn't just about leaking, nuclear launch codes. It's about something called contextual integrity. Sure, that person's contact info was probably public somewhere on the internet, but it was posted in one specific context. For an AI to just spit it out in a totally random new context, that's a whole different kind of privacy violation.
Which really leaves us with a big question for the future, doesn't it? We know for a fact that making these AI models bigger makes them smarter and more capable. But as this research clearly shows, it also makes them way more likely to memorize our data. So the challenge for all of us is, how do we keep pushing for that power without sacrificing our privacy along the way?